I'm from Alkami. My name is Bob Vandehey. I am the chief architect at Alkami. Alkami is a software development company where we have created a SaaS solution that provides online banking for banks and credit unions. So we go out to banks and credit unions, we sell them our services, and then we brand our product to make it look like their brand, and then their users go online and conduct their business using our software. When I started the company 6 years ago, we were just a little over 20 people, and today we're over 430 people. So we've been growing quite fast. We have 6 million users on the platform, and when Aaron was talking this morning at his talk, it sounded just like the journey that Alkami has gone through and is still going through. But what I'm going to be talking about today is, as we've gone through the componentization and microservice path, what were some of the patterns and practices that we put together, and what are some of the tools that we've created to help us gain some control back to that, right? So, as everybody, really we all started with a monolith. We had a monolithic application. It got to a point that it was taking 30, 40 minutes to build the application, and it was only getting longer. It was about 6 million lines of code spread out between a couple hundred different Visual Studio projects. Alkami, when we provide software, all of our software that we provide has to integrate with dozens of different interfaces. Because every bank is different. Every bank has different core systems that you need to connect to get the account information. They've got different credit card providers, different statement providers, different check imaging providers, different check ordering providers, everything. And so all of those we've created as separate projects in Visual Studio, and we've followed interface development, and all of that's swappable in our application. But it was all built at one time in one big monolith and stuff. And in the beginning that works really good, but over time it causes problems. So when you do have a monolith, and I actually just gave a talk yesterday at UTD to project managers, and really my talk there was to either convince them not to go down the path of breaking down the monolith, or if you do, there's a bunch of things you need to consider. So if that's something that you might be interested in, what are the things I think you need to consider if you're beginning your path to breaking down the monolith? I can share with you a presentation that I did yesterday that highlights a lot of things you should think about. But a monolith, the good things about a monolith, it is easy to build. It might take a long time, but it's easy to build. You got one script, you got one version, one thing, and it's easy to do. You can easily test that. You got one artifact that goes through the system. You got one test process, and it comes out of that, and you release it. And you got one big deploy that's got to go out. So all of that bigness, makes things slower and stuff. But the reality is, it's very simple. And as we started, one of the things though that forces, while it's simple, our monolith started becoming a complicated monolith, or maybe it was just a bunch of sticks thrown onto a truck. But it just started to look really, really messy and really, really problematic. This picture is interesting. I find it, there's a goat down there at the bottom. That's interesting. But this is like everyday life in India. This truck does this like every day. You would never see this in the United States. They wouldn't allow that. There's another picture where there's like 6 people sitting on top of it as it's driving down the road and stuff. But everyday thing. So anyway, things are getting messy with our monolith. So as it got bigger and bigger and bigger, the builds just kept getting slower and slower and slower and take longer and longer and longer. And so that was something that we really wanted to address. Testing, as it gets bigger, it also gets slower. We have to do and test everything when we release the artifact. So we really wanted to reduce the amount of testing we need to do on the application. And then, of course, because we're releasing this big whole thing, we had to bring down the site, install all these things. It took a long time, and we wouldn't do it very often because of the complexity and stuff. So we needed to componentize, and we needed to move to microservices. So, by moving to microservices, it allows us to have a lot smaller releases that we can build a lot quicker. We can test it because we only need to test what has changed in that. And in deploying, we only just need to deploy that one thing. But as you go down the path, there are some challenges that you have with breaking down the monolith. For one is growth explosion, right? So, in the beginning, we had one repository. They called it orb. Everything was checked in as one repository. But once we started breaking it down, we very quickly got dozens of repositories, and today we have hundreds of repositories that are spread out between a lot of different groups. And so trying to maintain control over all of those repositories was a huge challenge for us. You lose loss of control. So in the beginning when we had one monolith, the architecture team that I run was really in control of the whole process. But as we started giving everybody else control over their things, the architecture team lost control over it. But we still had responsibilities for providing, standard output and standard functionality. Package management becomes an issue, right? And when you have a monolith, you have one version that you really need to think about. And it's easy to communicate to your product group, it's easy to communicate to the release management group, it's easy to communicate to your DevOps group, and it's really easy to communicate to the customer. But now when you've got potentially dozens or hundreds of different versions that are all being released, all on a different cycle, that is a complexity now that you have to think about and how you manage that. And then where do you put all of those different versions that you have? How do you manage? Where do you go with them? Before we just output to a directory, you had one file there, and you could deploy that easily. A big problem with ours is version dependencies. Part of our application is unique in the sense that it is componentized. We can deploy things individually, but they all run in within the same IIS environment. And so one of the problems we have is that this release over here could have a version of a library that this release has a different version. And so that caused some issues with us. It's one thing when you have microservices and they're all fully sandboxed in their own environment, but we have what we call these widgets that would have a common environment they're all running, and so version dependencies became an issue. But even in microservices, you want to make sure that you're updating the libraries to newer versions, and as exploits are found, you're updating those too. So we need to worry about version dependencies. Complex deployments, with one monolith, it's quite easy. But now we have a lot of deployments going on all the time, and knowing what version I need to install where became a really big burden. And of course, then we needed compliance and security. We lost control. We had one process where we take the monolith, we send it on to Veracode that did static code analysis, and it came back a result. Now we have hundreds of different things being built in that. And how do we maintain the compliance and security that is required in a regulated world like banking? So this is our current tool set that we use for our CICD. We have Bitbucket as our Git repository that we have, and like I said, we have hundreds of repositories there. It's being monitored by Bamboo, which as changes are being checked in, it does the continuous integration and does the unit testing and integration testing there. And once it's finished building, we use ProGet to manage our packages of where they go. And we have an internal feed, which this is what goes to, that as builds are done, they go to our internal feed. And we've labeled our feeds. We have numerous feeds that we'll talk about a little bit later on, that we have feeds for dev, we have feeds for stage, we have feeds for QA, we have feeds for production. And we have a promotion process to move things through them. We also leverage ProGet's integration to WhiteSource to provide compliance. That provides the licensing compliance that it does there, as well as allows a report on packages on the feed for vulnerabilities. And then we added a product that we developed called SynchroFeed that helps us validate packages that are pushed to the feed, and we'll be talking a lot more about that in later slides. And then our SRE group uses Team City to do the deployments out to the environments that they do with whatever feeds are driving those deployments. So this is what our pre-release process is. So the development, we have about 20 development teams. They're agile teams, work on 2-week sprints. And each one of those teams has like their own list of projects that they work on. And as they're developing, working on a feature, pre-releases are automatically being built. And we add a dash pre build number at the end. And those all get pushed into a ProGet feed for the developers to pull into their development QA environment. Ultimately then the output of the whole process is it creates a chocolatey package that goes into the feed, and then that feed is that package is pushed to what we call choco.dev, right? So we have chocolatey packages, we have NuGet packages, and our chocolatey are the features that get installed, and the dev is just what environment it is. So since we're working on it in development, we push it into our dev feed. And then there is, one of the nice features that ProGet has is they have a webhook capability in ProGet that as packages are loaded into there, we have an AWS webhook website that gets called, which then puts a message into an SQS queue, which then is listened to by SynchroFeed to get notified that a package has been added, and then SynchroFeed goes through some steps to actually validate that package. This is just a screen of what WhiteSource looks like. So WhiteSource allows us to track all the vulnerabilities of all the different third-party libraries that we have on our system, and identify things that are out of compliance, have security risks, that might have just things that are out of date and time-based, or maybe have a wrong license. And this is just the management dashboard that you can do with it. So this, in our environment, is becoming more and more of something we really depend on. So SynchroFeed, I said we open source that. It's a tool set that basically is written around the concept of being able to interact with feeds like ProGet or the NuGet feed. It supports today NuGet feeds and chocolatey feeds, as well as a local file directory, which is treated just like a repository. And the concept in SynchroFeed is that it's just a repository. But then SynchroFeed has extensions that you can do. And so one of the things that we are doing at Alkami is different teams, as well as the architecture group, writes extensions that get run, and it runs these checks and validations against every package that gets pushed to ProGet. And we'll talk about a lot of the different things that it does. It's an extensible framework though, so if there are certain things that you want to do that we didn't think about, you can add what's called a command that extends out the framework here and does whatever type of validation or action you need it to do. These are some of the things that we do today with SynchroFeed. So all of these are, without things that don't have the Alkami name, are on our open source GitHub project. But first thing we do, we had a lot of problems with people releasing things that weren't 64-bit. The main problem that causes is that if you have 32-bit and 64-bit things running in a .NET world, you have to have configuration for 32-bit and 64-bit. So it was causing problems on our DevOps team to always keep those configurations in sync. So we wanted to make sure that we didn't have any 32-bit processes in our application. So the first thing this does is it validates that there aren't anything that's 32-bit in here, and it'll fail the package if it finds it. And then we have added for internally our Alkami Validate configuration. This just goes through and looks at like a lot of the logging settings. Some of the problems we had was different groups use different logging settings, even though we had a standardized format that people should follow. Sometimes it didn't do it, or sometimes a developer would make a change in their development environment to increase logging and then committed it to the source control. And then what we get in production is an elevated level of logging. So we check things like the logging level through this, as well as some other configuration things, making sure naming conventions and all that is right. And then we have this validate assemblies that goes through that makes sure only the current version of assemblies are referenced. So this is managing the dependency managements that we have. Lets them know that, hey, you've just committed something to ProGet that is using an old library, and you should update that, and that's what that does. And then the very last thing, this helps us understand our dependency management, and as well as being able to track what is affected when something changes, and that's we have a process called catalog. And catalog takes the package, unzips it, goes through and reflects all of the assemblies that are in there, determines all of the dependencies of all the different versions, and throws it into a SQL Server database that's then searchable for you to be able to do it. So every package ends up getting into a SQL Server database. This is an example of SynchroFeed and Slack. So the other concept that SynchroFeed has is it has listeners that can output and do different things. And so we have a Slack integration built into there. So as issues and things are found, our developers monitor a Slack channel that will highlight what the problem is, what it found, and there are links in here that work and stuff. That's also extensible if you wanted to interface to something else, be it SMS, email, or whatever. You can extend that through SynchroFeed as well. So this is what currently our pre-release deployment process looks like. We're going to step through really each step that we go through, from pre-release to QA to stage and prod. There's subtle differences between them, right? So, we have our, up at the top really is our Chaco dev feed. It goes and the team QA is testing it right here, making sure it all works properly. In their environment, we have a Chaco install that installs it in this environment. They go and test that. And at some point in time, QA goes and makes a determination that this is working properly, and they manually use the promotion capability within ProGet to promote that from the dev feed to the QA feed. We actually have that integrated to an API, but it uses a promotion API to be able to do that. And so then it pushes that package out to the Chaco QA feed. Our different environments look at different feeds to be able to pull them down in when you deploy. So the install scripts are all the same regardless of what environment. The difference changing is what feed it's actually looking at to know what versions it needs to pull and pull into it. Staging is very similar. It goes into what we call a QA integrated environment there. QA again runs through all the tests. When they're satisfied that it's working the way they want to do it, they actually notify release management, and now release management is actually responsible for creating what we call a release ticket and promoting that from the QA feed onto the staging feed. And then once it's in the staging feed, the process is very similar. There's more testing done in the staging feed. The staging feed for us is where it gets into a production-like environment for all of our different customers. So QA goes out there and runs a lot of automated regression test scripts against it. Our customers can even go out there at this point in time and will be testing against it and opening tickets and issues. If all goes well and it validates, then again, release management approves that ticket to go into production, and another promotion is done through the ProGet promotion API to promote it from stage to production. And then in production, it just pulls from the production feed down into production, and that's the end of the process. We have, like I said, a lot of different feeds. So Alkami has not only internal developers that do development on our system, but we have third-party customers and partners that develop our system using our SDK. So if they want to develop extensions to our application, we do that through the SDK. But to do that, they also need access to all of our internal feeds. So we actually have two ProGet systems. One's our internal one, which is hosted in our internal network, and one is an external one that's hosted out at AWS. But we do, through SynchroFeed, mirror every package that gets put into the Choco Dev, internal, gets posted to the Choco Dev external, and all the way across the board. And we couldn't use it to just, ProGet has mirroring. We couldn't just mirror it because the one in AWS could never have access to our internal feed. We just wouldn't be allowed. So, I think by using these tools and the process that we have in SynchroFeed, it's helped us to manage the growth. So the growth is going to happen. We're going to continue to add teams. We're going to continue to add growth to that. But, being able to get a little bit back of the control that we needed of all the changes that are being made to the environment to be able to validate that all the changes being made are meeting our company standards, that the newer versions of assemblies are being used. It's allowed us to get a lot of control back. Also in SynchroFeed, it allows us to validate that the teams are following our standards. The package management through ProGet and all the different capabilities that ProGet provides, it allows us to manage all those different packages, all the different versions, allows us to roll forward and roll back, be able to see what's in there, able to use the promotion API of ProGet to be able to promote it through the different feeds along the path that we do. And then it also allows us to help through SynchroFeed manage the dependencies, all the different dependencies we have in our application, make sure that the versions and everything are correct. The complex deployments, by having different feeds for different environments, it allows our SRE group to pull the scripts down, pull the packages down from the appropriate thing into the environments, simplifying the deployments that they do. And then from compliance and security, one of the things I didn't talk about, we also have a package that integrates to WhiteSource and pushes continuously the packages to WhiteSource in another way that gives us some additional capabilities that aren't available directly, natively through ProGet. But WhiteSource is providing really all of the different types of compliance that we need. So, any questions? Yes, sir.
Yeah, so it looks like you did, and I guess the question I have isn't specific to this, but more, it looks like this is a really cool investment in your own tooling, if that makes sense. Like, all the code you wrote for SynchroFeed didn't directly deliver business value to end customers, like it wasn't what your regular developers doing. How do you get buy-in internally to invest in writing your own tools when maybe some people are like, you should be writing code that helps our customers?
Sure, that's a constant problem we have at Alkami, right? We have a product group that is mostly focused on the needs of our customers. A lot of this happens from just a lot of the hard work that me and others in our group do, finding the time to do it. It's something that we know is going to make our lives easier, something we know we need to do. So maybe there's, carving out a few times during the day, but spending a lot of nights and weekends on this. So personally on SynchroFeed, that has been my project that I've spent, a lot of nights and weekends really taking the tooling that we kind of did internally and just making it better, making it open sourcing it and all the things that are required for open sourcing stuff. Making sure it's all well documented and the patterns all work and the build process is all there and the packages are being created and stuff. So it's a challenge. Yeah. But I would also say, one of the things that most companies don't have, and we slightly have it in my group at Alkami, is we don't, my group has no client commitments, right? We are an overseer across a lot of different groups. We work more on a Kanban style, and we are able to control our time a little bit better than everybody else. So, many times that means we get pulled into emergencies because we can be available for that and do that. But it also means that there are a lot of times that we see a problem, we can jump on it, solve that problem, and get it done. I really think every team, every company should have a group of people that has, just bench people. They're not assigned capacity, because we all have these problems that we need to solve that through more automation or whatever would make it easier. But most companies just don't have the budget to do that. Good question. Anything else?
I guess I wanted to get your thoughts. Do you think that anybody, I really liked how you described the monolith.
Right.
And what I wonder is, do you think anyone sets out to build a monolith? Or does it always start small and grow? And then if so, how do you know when you're building a monolith?
Well, I think it does start off small, right? I mean, I think if all of us knew the journey that we would go through to develop any of the products that we probably start with, we'd probably not go down that journey. It turns out it's always far bigger. And in digital banking, people look at digital banking. We go out to customers all the time, and the larger customers are always debating, well, we should just develop it ourselves instead of paying Alkami these millions of dollars. And they just think, well, it's just banking. It's easy, right? I've seen some accounts, some balances, transfer some money, no big deal. But it is so much more complicated than that. There is so much more to it that you really don't think about. And not just to mention from the compliance standpoint, the security standpoint, managing the infrastructure standpoint is a huge thing that Alkami does for our customers right now. I mean, credential stuffing attacks and all those type of things that happen really, really extensively now in the banking world, where constantly robots 24/7 are taking the billions of credentials that have been loaded up into the dark web and just attacking a website with it, constantly trying to get through. And so being able to manage that and stay ahead of that is a lot of the challenges that we have. And so all that adds to the software and the complexity and growing. One of the things I said in my talk yesterday is, even if you're building a monolith, you should build it like you were componentizing it, like you were planning it to be a more microservice-based architecture. And Alkami actually did that for most of its applications in the beginning. Like I said, we had hundreds of projects, right? We had about half a dozen different solutions, and each one of them had anywhere from 20 to 100 projects in it. Each one of those were broken down based on the type of solution it was bringing. So we'd have some projects that it would have 30 different e-statement providers in there and 20 different check imaging providers. And so we broke it down already into smaller pieces. And so I think that's one of the things that everybody really should focus on in the beginning before moving to a microservice-based architecture. Yes?
So that one big monolith you had, do you break everything that was in that monolith into a microservice, or do you have a hybrid?
We have a hybrid. So our goal and our journey is to completely break down the monolith, but we still have a large portion of our code that's depending on that monolith right now. So one of the things that my frustrations is that the product team doesn't spend enough of its time continuously breaking down that monolith. And I've made the comment that we should stop releasing any new versions of what we call orb, which is the monolith. And if there's any changes that are needed, it will force you to pull that code out and put it into a microservice if you really want updates on it. Because the biggest problem we have, the microservices stuff that we deploy is actually fairly quick and easy to deploy. But the monolith, it takes an outage, it takes a lot of work, there's a lot of issues that you have to do with, that Aaron talked about, being up at night and making sure that it all works properly. Most of the microservice stuff we can all do hot during the day, continuously, and stuff like that. So there's a lot of advantages to Alkami to have everything microservices based. But again, focusing on features and what the customers want product really doesn't see always the importance of investing in microservices. Yes?
So how do you avoid the issue of like interdependencies between different repositories? Because like, I think you can have like so many different interdependencies between different pieces that it is effectively a monolith, even if it isn't.
Well, I can't say we control that. Everything is through an API, right? If you are going, you can't go to the database. If you want this information, you got to call the API of that service over here. And we have about a dozen or so core services that everything uses. I mean, if I need to get an account, I'm going to call the accounts microservice. If I need transactions, I'm going to call the transaction microservice. If it's security based, I'm calling our security microservice. So, everything's integrating to those. So I don't really worry so much about what's integrating to my stuff. It's just how they're integrating to it. And by making it focused on the API that we have and the contract that we have, as long as I maintain the compatibility of that contract, I should be able to upgrade that microservice at will and not really worry too much about the dependencies on that. And so from your standpoint of why is it still a monolith if everything's talking to, let's say the accounts microservice? Well, no, because I can, if I do fix just the accounts microservice, I just have to test just the accounts microservice. I just have to make sure that the contract on it and behavior of that still behaves the way it did all along, even though there's maybe hundreds of different places in the application of calling that particular part. Yeah.
So leveraging on that, this is something that I have been curious about since I started my career with the Windows DNA experience.
Right.
And this goes back to this same sort of building a monolith out of a lot of little pieces. So I've seen this happen time and time again. The first was that Windows DNA experience where every COM interface had a separate interface that was independently versioned such that if you ever need to change they didn't call them microservices, but they called them COMs, right?
Sure.
Just deploy the COM. And at the time I didn't get that it was microservices, but then as I started watching, as we do process consulting with product, I started watching some customers built this is a long time ago, but they built microservices, all web services, right? All web services.
Mm-hmm.
But the problem was they could never keep the dependencies tracked. So what they would always do is instead of deploying one app, they deployed all of their microservices. What I can never figure out is how do you keep track of, and the problem is people would keep forgetting that one version depended on another. They would never be able to test all components of the contract. Even though the API said it was the same. So what they ended up doing to mitigate the risk of constant, even though the contract was the same, the behavior was different. They deploy everything all at once. So how do you keep up with dependencies? I guess is the ultimate question. Like whose responsibility is it to manage all, as the microservices grow into this huge interconnected system? Does SynchroFeed give visibility into this? What can you do to make sure that you don't end up with 1,000 microservices that all have to be deployed at once?
Yeah. That is the great challenge of moving to microservices and breaking down the monolith is all the dependence that you get. And that is, nobody has solved that problem. All SynchroFeed does is give you a database that allows you to mine it to help identify what those problems and dependencies are. At the end of the day, each team is responsible for the artifacts that they create. And they are responsible for the testing that needs to happen to ensure that this is compatible with everything that depends on that. And do they make mistakes from time to time? Sure. Hopefully we catch it in QA or stage. But sometimes it goes out into production, and at least with the process that we have developed, we can usually make a change and get it out there and fix it fairly quickly. So it's usually not hugely impactful.
So SynchroFeed lets people who, it lets for example, if I publish a microservice and then people take dependencies on my service, one of the things you did with SynchroFeed was allow me to know who's depending on me.
That's right.
Like a reverse dependency.
That's correct. And so then we have our product people actually have access to the database that has all this information in it. Ideally, someday we'd love to build an interface on top of this that you can actually display it in a more user-friendly mode. But right now, our product people, they go and query that database for dependencies. If there's a change that they make in some very common query they do is, what are the other things that depend on me? So, you know, they can figure out where that dependency chain is. They can notify other people if they're making some breaking change, or just even curious of just saying, hey, you might do some testing. I just made some major change to this. It might be compatible, quote, but I just want you to test anyway to make sure it does. And that's what the database, the catalog portion of what SynchroFeed does.
So I don't know if that's called reverse dependencies, but that sounds like that could be a major solution to this dependency mess, because you never know who's depending on you, just the other way around.
Yes, yeah.
Very interesting.
So, yeah. Without that, it was just a growing mess of nobody really knowing what all those points were. And, you know, when you create, especially our platform services like accounts and transactions that are used everywhere, you know, we just didn't have any way to be able to tell who's dependency, who's using that service. Or any team at any day could add a new reference to some external microservice we had. This allows us to identify all of those dependencies that we have in our application.
Is this something that you think Inedo and ProGet should investigate? Is this concept of reverse dependency? We've had customers ask things like, is there a way for us to know who's consuming packages for which application? And we always say, well, you can look at web logs, you can look at requests, but this idea, I mean, if you built it, it sounds like, yeah.
Well, I think, would ProGet be a better product if I can go in there and say, what are all the things that are dependent on my package? Absolutely. That would be a great interface that we would use today and not do a lot of that we're doing with SynchroFeed. So it's different than the dependency you were talking about. What people might be asking you is, who are all the people that have pulled my package and are maybe using it? What I'm trying to say is, what are all the packages that are in this ProGet repository that actually have a reference to my package and depend on my package? Your challenge would be, how do I determine that this package over here has a reference to that package over there, right? We do that, we can do that internally because of the naming conventions and things that we use and the patterns that we do. Every microservice we have has a corresponding client package. And so we can tell this client has the same name as this microservice, so we can tell the relationship between the two very easily. Your challenge will be, how do you genericize that and determine that across a lot of different types of packages?
Right. No, your approach is very interesting, and I think if you want it, you got to do something like, standardize.
Right.
It's cool.
Yeah. Anything else? All right. Well, thank you very much.